Hi there. Thank you all for coming. It was probably about 30 years ago I gave a talk up here on surface geochemistry, so it's been a while. But I'm from Denver, Colorado. I'm an operator in Kansas, Missouri, Utah. I operate the gas wells at Fort Knox in Kentucky, and I'm active in helium, wind and solar. So I'm in the energy business. Not into hydrogen yet because the jury's still out, but I'm talking today about helium, which is a niche part of our business, oil and gas. And right now, an MCF of helium goes for $400 US. So it's a very lucrative business out in Western Canada. In Saskatchewan, a couple companies have taken helium production from 0 to 5.5% of the world's supply. So it's very much a sought after element. It's also a very critical element. So what do we use helium for? Well, without it, we can't run modern society today. Welding is very critical. The best atmosphere for welding is with helium. It's in cryogenics. It's in all sorts of things that you just don't think about. Computer chips can't be made without it. If we did, they'd be a lot different than nowadays. So without helium, the bottom picture is what the computers would look like today, which is from the 1950s. So it's very critical for our tech society. The demand for helium is growing every year. As a matter of fact, Southeast Asia is consuming most of it because that's where the world grows most of its chips. So what is helium? Well, it's other than hydrogen, it's one of the smallest atoms out there. It's very non-reactive, doesn't react with anything unless you have high pressures and high temperatures. And then it only merges with or combines with krypton and xenon. So it doesn't form any compounds. It's neutral. It's present in some natural gas reservoirs, about 17% of the gas reservoirs in North America. And we think it's actually present in more. We're now finding out that hydrogen is present in a lot of these natural gas reservoirs, but we didn't analyze it for years, so we didn't know that. But essentially, it's composed of two isotopes, He3 and He4. He3 is very uncommon. As a matter of fact, the only place you can buy it from is from the US Army or the Russian military. It's very rare. He4 is derived from the crust in the mantle, and it just migrates up in certain areas. We don't really understand where the helium is coming from, but for the most part, it ends up in certain areas in the West in large quantities. Helium is derived from uranium and thorium, also lithium. It's a byproduct, but a lot of the helium that we think we are producing is when the Earth was formed 4 or 5 billion years ago, whenever that was, and was trapped in the Earth's core and is now migrating slowly up to the surface. There's some problems with the source of helium because there's a lot more helium that we're seeing than we can account for. And then the moon has become a target of the Chinese to mine helium. The surface of the moon is covered with a thin layer of helium. There actually was a movie with Sam Rockwell out using that as a backdrop on the moon. So people are starting to look at where they can find helium cheaply and efficiently. The Chinese right now have really no sources of helium, so they're trying to tie it up somewhere. Helium production has gone up and down, but in the past few years has accelerated because of the use in computer chips, cryogenics. Medical equipment is critical. Medical equipment is getting better. They're using less and less helium, but still for the computer chips, it's growing. There's 5 places that produce most of the helium in the world. And that's in LaBarge Field in Wyoming that Exxon produces, Qatar, Algeria, Russia, Texas Panhandle, and down in Texas and Oklahoma and Kansas. The number of facilities, unlike oil refineries, is a lot smaller. There's basically 5 companies that purchase helium that resell it to everybody that uses it, Linde, Air Liquide, Messier, and there's a couple others. So it's a sort of a cartel, like an OPEC of helium. Learning about helium is very difficult. It's a very opaque industry. Most states, unlike Canada, report the helium production. Some states have royalties, but not very many. So we don't really know how much is actually produced in some cases and actually sold. Linde and Air Liquide don't release figures, and they're the 2 largest. So this is just a model of how it migrates. It's a very cartoonish model because we really don't know exactly where the helium will come into the reservoir. It could migrate from adjacent faults or faulting just beneath it. But it simply is the helium comes from somewhere deep in the crust and the mantle in order to accumulate with natural gas. And typically Paleozoic rocks are what have helium accumulations. We do see them in shallower ones. I found a couple out in Utah in Cretaceous rocks, but there's no Paleozoic rocks underneath them. So essentially, it's trapping in the first sandstone or carbonated finds. So this is a map that shows you where all the active areas are. The major production, like I said, is Labarge, Texas Panhandle. Also, central Kansas at one time was very productive. Central Kansas and the area up in Alberta and Saskatchewan are primarily from Cambrian sands. And that's why Ontario interested me, because there's Cambrian sands here with reasonably good helium numbers. As a matter of fact, an economic helium field has 1% helium that you extract. If you had 3 BCF of natural gas and 1% helium, the natural gas at $3.50 would be worth about $10 million. The helium, remember it's 1%, is worth $12.5 million at present prices. So it's quite a difference. And there's some areas that extract the helium as the gas is processed through the pipeline. Texas Panhandle, Hugoton is one. But the areas most targeted in the past 80 years has been in the western U.S. Something to note is that Ontario actually had the first processing plant back at the end of World War I. The British found if you added 10% helium to your dirigibles, which were 100% hydrogen, they didn't explode when hit by machine gun fire. Anyway, the first plant was put here, but by the time they got it up and running, the gas fields they were next to were depleted. So they moved it to Bow Island, Swift Current area, and established the first helium production in the world. General characteristics. A lot of people glob on to very high numbers like 10 or 12%, whereas the most productive areas are less than 2%. The big 5 areas in the world are generally less than 0.1 of 1%. Like the Labarge field is producing CO2 for EOR in Wyoming, but they're extracting millions of helium every year as a byproduct. And so Algeria is the same way, Qatar's the same way, the South Pars field. The North Pars is now being exploited by Iran for helium and their nuclear program. And the Russians have been obviously blockaded or embargoed, and they're selling all of their helium to China. But it's the higher heliums that seem to initially attract people, but those have very low reservoir pressures, sometimes significantly underpressured, and they don't produce very much helium as compared to the ones that are low percentages, because they tend to have high gas flow rates. Usually the host gas is methane, but it can be nitrogen or CO2. This is the present area that we see anomalous helium is up, a recent sort of discovery up in Minnesota, the Michigan Stray sand in the Michigan Basin. There's been analysis here in Ontario that shows good helium. Unfortunately, those fields are depleted. And then I'm active down in the Rome Trough, which has similar helium to the Ontario area. Both are targeting the Cambrian sands. So we're going to start with the Mid-Continent Rift because other than the London area, the other fields are associated with it. On your left is a cross-section through the Kansas portion. You can see the intrusions and the gabbro flows and the lava flows. And in the southwest part of the rift system in Kansas is being targeted for hydrogen. And once again, they find wells with 96% hydrogen and the rest being helium. But unfortunately, they flow 5 MCF a day. So if hydrogen was to work, you need to get to 30, 50 million a day. And so far, worldwide, we're not seeing that. But very good helium numbers, but unfortunately, they're not economic. And then you can see how the Mid-Continent Rift loops around and heads down into Kentucky and Tedesco. And this is just the gravity and aeromag for the Mid-Continent Rift. It's very distinctive. We're seemingly finding new arms of this rift every few years. Recently down in Ohio, eventually into Kentucky and Tennessee by drilling. And recently a friend of mine showed me a 3D seismic project in central Kansas, and we found another part of the rift that's not on here yet, but I assume it will be shortly. The first place we're going to talk to is Bald Eagle. It's been drilled by a company called Pulsar Helium. It's a gabbro that's got 10%, 14% helium in it at 2,000 feet to 5,000 feet. A lot of helium top to bottom. Unfortunately, the flow rates are like 100 MCF a day. So it's not, I don't think it's going to be a significant area, but it's got several people excited, especially at the USGS. As I said, the original reservoir was discovered by a mining company looking for nickel. This area is heavily mined both in the US and Canada. And actually, I work for a Kerr Addison at one time, and they had a uranium mine on the opposite side of Lake Superior from the States. Very interesting area for all sorts of minerals. Now it's got a small deposit of helium that's trapped in some gabbro that's been highly fractured. Interesting that it has porosity, but it's being developed as we speak. Probably won't produce for another year or two. But you can see the bottom hole pressure is at 144 psi, which is at 2,100 feet. That's very low. The next area is the Michigan Stray sand. This is typical Michigan basin. These are sands that are right at the Mississippi and Pennsylvania boundary. They're considered a rework of lower sands. The Cambrian stratigraphy is defined by one well, by the Sparks number 1, found Rome equivalent sands down there, but no gas in it. And that well was drilled in the 70s. It was a random well to test the rift system. Since that, there's been no testing of the rift system like there has been in Kansas, Nebraska, and Iowa. But essentially, there's anomalous helium in the sands. They've all now been converted to gas storage, so their value is, other than a geologic discussion really, is to indicate that there's anomalous helium potentially deeper. It's just an anomaly. And then if you can see the numbers, we get up to over 1% helium in these shallow sands. They actually would be economic right now if they still had the gas in them. And this is a cross-section through the Mississippian sands up there. Amazingly, these are the only logs that I found for like 500 wells through this sand up there. A lot of the wells were never logged, but it's a good clean sand. Wish it had oil in it. It'd be better right now. The London area is basically on the Algonquin Arch, and these sands had been tested by previous gas analysis, and subsequently it shows 1 to 1.5% helium, which is very lucrative. Shallow depths. Now this is the stratigraphy. Basically the Mount Simon sand is all over the mid-continent. It's called the Reagan in some places. And then you have the Eau Claire and the Trempealeau. It's very consistent lithology in a lot of basins in a lot of areas. And it produces pretty well for natural gas and oil in some areas as well. This is the Clearville field. It had nice numbers in the gas analysis. I don't know what amount of gas it produced, but if it had been discovered today, I would have taken a hard look at it to see if it had enough gas to make it economic. One of the big factors stopping people from doing helium is that the processing plant you'd put on the well or wells cost $3 to $5 million US. And that's a big stumbling block for people because that type of commitment for small operators or even mid-size operators, because sometimes when people start producing helium, they suddenly, 6 months later, there's no more helium. And we still don't understand why. We get these nice numbers and then they disappear. And if you have a 10 BCF field and you have helium, usually it's in the uppermost part of the structure. It's generally all related to structure because helium likes to go up and it moves very quickly. This is the Goebbels field, similar sort of thing, small gas cap with some really, really good numbers. So if anybody's looking for Cambrian sands and structures out in Ontario, they should be thinking about helium as well. And I understand there was somebody with a helium well a couple of years ago somewhere in Ontario. So the London area, it's got a lot of good things going for it here, except that where do you go? Because a lot of people don't typically go after the Cambrian below, like say down in Leamington area, because that's an area where there's Trent and Black River. And the seal for the Cambrian sand seems to be these dense limestones. The last area I'm going to talk about is the Rome Trough. This is in Kentucky, an extension of the rift once again. It's a very distinct trough. It's considered part of the Mid-Continent Rift. It swings around from West Virginia down into Tennessee. The largest field in the state of Kentucky, 100 million barrels that was just plugged, is sitting in the trough. There's really a lot of undrilled areas. There's a lot of big structures we're finding on seismic, never been tested. And the Cambrian sand sits at about 6,000 feet. So it's a relatively good depth. That's the same sort of depth in Saskatchewan where they're getting good results out of the Cambrian sands. And you can see the few numbers that we have, over 1%. This is very economic. Here, like in Saskatchewan, the host gas is nitrogen, which is sort of a downside for helium because you want a lot of power to run your processing facility. And so we're looking at the St. Peter above it. We're near a field that made 8 BCF of gas, so we're starting off targeting those, and then we'll drill deeper on the same structures for helium when it's appropriate. This is just a log with the geology showing where the Rome sandstone is. There is other sediments below it. In some areas, the Rome sits right on the Precambrian basement. But the Rome Trough has a lot going for it. Regulations in the state of Kentucky, like Kansas, are a lot less stringent compared to, let's say, Ontario or Colorado now, or California, that sort of thing. It's a good, easy place to lease and drill. You can get a permit in 5 days, same in Kansas. It's very industry friendly. In summary, there's several areas in eastern US and Canada that are potential for helium. A lot of the data we have is very old in terms of natural gas analysis, and the equipment back then was not as good. So there's still a lot of opportunity to find helium, especially along the rift systems. And except for Minnesota, there's no tax on HE production. As a matter of fact, in Kansas, they treat it as a waste gas, so they don't even pay royalties. We don't do that, but some people do. And Ontario has a healthy oil and gas industry, which I think gives it an advantage. And the geology of eastern US and Canada is probably just as well known as it is in the West. So finding targets fairly easy. Thank you for coming, and I wrote a book on helium, and it's on Amazon and Elsevier.